The word Schlieren comes from the German word Schlier, that means streak. It is a photography technique that is a way of visualizing the flow of fields of varying densities. The shimmering effect seen on hot surfaces on sunny days is also due to this effect. If the fluid flows uniformly, the image remains steady, but if there is any turbulence, a variation in apparent brightness occurs, which is also known as scintillation. Robert Hooke first used this technique in the 17th century, and it was reinvented by German physicist August Toepler in 1864. Schlieren then became a standard laboratory tool for examining shockwaves. The technique could not improve due to the technology. It wasn't until the availability of digital imaging that things improved greatly. From this point on, Schlieren is available to do at a much lower cost, with higher accuracy on the resulting images. In order to perform Schlieren, you will need a printed sheet of the moire pattern, a camera or webcam, and a heat source. Firstly, a moire pattern needed to be printed off. Effective patterns include narrow horizontal or vertical lines and small random black squares. The moire pattern is mounted, in our case with blue tack to the door. Next, the camera in use, a laptop webcam, is positioned at a distance such that the features of the moire pattern are just blurry. Next, the lights were turned off, and a light source is shone towards the moire pattern to provide some illumination. Recording was then started, and a reference image of the moire pattern was taken, which will be used to discern differences on subsequent frames. An object producing heat was placed in front of the moire pattern. The traditional method of Schlieren involves using a parabolic mirror. The mirror turns the light source into a collimated beam, which will spread minimally, so therefore the light is focused onto the target object at the center of the mirror. A knife edge is placed at the focus of the mirror in a position that will block half of the light being reflected to the object. Normally, this would just make the light half as bright. However, the same thing occurs in this variation of the experiment as the one without the mirror. This means the beam of light is not as focused as it usually would be, and half of that light is blocked by the knife edge, resulting in a set of lighter and darker patches correlating to the perturbed density gradients.